So I am Professor Lead, Monica. My email address is mmlead@acc.edu. My phone number is 240-675-0445. So, again, if you want a copy of the paperwork that I will write on the entire class, please email me to mmlead@acc.edu. If you want the recording, because I'm also recording separately on a different device, if you want the link to the recording, also email me to mmlead@acc.edu, and you will get everything we will complete today. I'm ready. Melissa, you have the floor.
Okay, so the problem says 3x cubed plus 2x squared equals 12x plus 8.
12x plus 8, correct?
Mm-hmm.
Good. We are asked to solve this equation.
Yeah.
Perfect. First thing first. So my first question to myself is, what is it? Type. Because if it's logarithmic, if it's exponential, if it's quadratic, if it's I have to identify it first. Assuming that once I identify it correctly, I will know how to get to step 2. So can anyone tell us what type of equation is this? It's very important. It's like basic learning, basic language skills, right? If I don't know what it is, if I can't translate what this is, then probably I don't know how to solve it. So can anyone tell us what type of equation is this? It's okay if you're wrong. Just please talk to me, please.
Is it a polynomial?
Excellent. It is a polynomial equation. Brilliant. Now, because you said polynomial, I have to find the degree. Can anyone identify the degree of this polynomial? Can anyone identify the degree of this polynomial? Oh, I see that. Michelle said 3. I agree. Number 3 is, please remember, if it's a polynomial and it has degree 3, we have to find how many solutions?
3.
Exactly 3. Brilliant. Awesome. Degree 15, 15 solutions. Real, imaginary, we don't care. If the degree is 3, we have to find 3 solutions. Awesome. Perfect. Now, every time we start or we have to solve a polynomial equation, first of all, we have to set it equal to 0, and we have to arrange all these terms in descending order. When I move a term from one side to the other, the only thing that changes is its sign, nothing else. So I will have 3x cubed plus 2x squared minus 12x and minus 8, and that equals 0. So because there are 4 terms, what is the pretty much only method that I can think of when we talk about 4 terms? 4 terms or more. There are variations, but in general, what method will I think of?
Grouping.
Yes, absolutely. Great, brilliant. Kelly, thank you. Grouping. And remember, I'll try the first 2 and the last 2, but then if it doesn't work, I may have to try these 2, to group these 2 and then these 2. Or maybe eventually these 2 and these 2. First, let's try that particular order. So now, see, I have all my props here. What will you factor out from the first 2? From the first two terms, what will you factor out? Say it again. X squared, very good. What is left in parentheses? Remember, two terms, we need two terms. Very good. What has to, do not uncover this. What do I have to come out to see coming out from the other two? Otherwise, if it's not there, I cannot continue. I refuse to look. Excellent. Who was that? Thank you so much. If I do not get the 3x plus 2, I cannot continue. I cannot fabricate it. It must be there. But if I don't get the same thing, then I cannot continue. So now let's uncover and decide. I need a sign and I need a factor. A sign without a factor or a factor without a sign will not work. I need a sign and a factor. What will you pull out from the last two terms? Sign and factor.
-4.
Excellent. Let's check. Negative 4 times 3x? Yeah. Negative 4 times positive 2? Yeah. Good. Now we have two terms. We reduced those 4 into 2. What do they have in common? Because I have to pull it out. What do these two terms have in common?
The sign. 3x plus 2.
Indeed, the 3x plus 2. What is left in parentheses? This is gone because it's outside. This is gone because it's outside. What is left in parentheses?
X squared minus 4.
Brilliant, thank you. This can be further factored, as we know. How do we factor x squared minus 4? Anyone, please help?
X minus 2 and x plus 2.
Brilliant, thank you very much. Can anyone give us three solutions?
X minus 2/3.
X equals?
X equal
Yes.
minus 2/3.
Very good, awesome, brilliant, brilliant, very good.
X equal 2. X equal minus 1, minus 2.
Very good, awesome. Let's take a moment and see if you have questions. If you have questions and you don't say anything, it's a mistake. If you have doubts, if you're not sure about something, please speak up.
Professor, how did you get -2 there?
This one?
Yeah.
X. So this is the zero product principle. Zero product principle. We have 1, 2, 3 in this case. 3 factors. Factors because they are multiplied. If a product of zero product principle. If we have a product of 3 factors and the product is set equal to 0, then the first factor can be 0, then the second factor can be 0, then the third factor can be 0. When you set this equal to 0, you move 2 to the other side, it becomes negative, and you divide by 3. When you set this equal to 0, you move -2 to the other side, and you get x equals 2. when you set this equal to 0, you move 2 to the other side and you get x equals -2. Is that okay? Is that good enough?
Yes.
So you set this equal to 0 as an example. You do the same thing to all of them. And you have x equals -2. Because you have to move this term to the other side in order to solve for x. So you get x equals -2. Better? Everyone?
Yes. Professor, I have a question.
Please.
How, you see, second line, x squared minus 4, no, above it, x squared, yes. How do you, can you explain how to get minus and plus at the bottom?
Here.
Yes.
Perfect. So we do have a formula, or a special product better, that is called a squared minus b squared, which is the difference of squares. And this factors into a plus b times a minus b. You can factor it the other opposite direction or order, it doesn't matter. So it's either a plus b times a minus b or a minus b times a plus b. So here we had x squared minus 4. And we will, first of all, we know that this is a perfect square, this is a perfect square, so we will be able to use the difference of squares. So now the question is, what do I square to get a squared? What do I square to get x squared? Well, it has to be x. What do I square to get 4? Well, it has to be 2. Is this okay?
Yes.
So this is the formula called the difference of squares.
Thank you.
Thank you. Very good questions. Is there anything else on this problem or other problems? Do you need help with anything else? Melissa, is this better?
Yes, thank you.
Good. Did you have something else for us to work on?
Not right now.
Okay. Does anyone else have anything else? If not,
Can
yes?
it be anything? Can it be anything?
You mean this B?
The question, no, you said we can ask any other question.
Oh, yeah, I don't know what, yes. So it's a new question now. Okay, go ahead.
Yes, I have a bit of problem with exponent.
Okay, can you give me the problem?
1/3 exponent 3.
The whole thing or just here?
The whole thing.
Like this?
Yes.
Good. In this case, it's the same. Good. What do we do with this? Is there anything else or just this?
Equal x. This equal x.
Like this?
Yes.
And we just have to simplify this expression. What is the problem? Do we have to do anything else with this x or just simplify this?
Yes, simplified.
Okay, so every time we have a fraction raised to every or any power, we have to raise the numerator to this power, and we have to raise the denominator to the same power. So in this case,
Okay.
1 times 1 times 1 times 1 is 1. And we have to raise 3 to the same power, which is 3. 3 times 3 times 3 will be 27.
Okay.
Is that it? That's it?
Yes.
Okay.
I wasn't sure if we needed to add or multiply, but now I understand. It's 3 times 2
So when
times
we
3.
have a to a power n times a to a power m, my n has 2 bubbles and my m has 3 bubbles, then we add the exponents.
Okay.
But here we don't have, first of all, a product. Then when we have a ratio, a to the n over a to the m, we copy the base and subtract, always in this order. From the numerator, from the exponent of the numerator, we subtract the exponent of the denominator. And of course there are other rules as well. Like for example, a raised to n and everything to mth power. Now we multiply the powers. I think Matthew had a question. Do you still have a question, Matthew, please?
I actually figured out what I did wrong.
I love it.
No.
I'm not lazy, but I love it when my students answer their own question. That's brilliant. Good. Anything else? Is there anyone else before we start chapter 2?
Sorry, ma'am. The question I just asked, that was multiplied. If it was, for example, 1 over 3 plus 1 over 3, how do I do plus 1 over 2?
Well, these two fractions have the same denominator. You copy the denominator and you add the exponent, the numerators. Sorry, this is not an exponential rule.
Okay.
This is just adding fractions.
Okay, thank you very much, ma'am.
Thank you. Are there other questions? Other questions? Okay, so in that case, let's start chapter 2. That's all about functions. And I'm sure that for some of you this is a review. What is a function? Well, a function is a relationship. So a relationship that connects different values. The so-called x values and so-called y values. So this number, I'm just going to put some numbers in here. 2 and 4, negative 3 also goes to 4, and let's say 5 goes to 0. This is a function. Why? Because each x value corresponds to only one y value. Each x value corresponds to only one y value. Each x value corresponds to only one y value. This situation is not a function. Does it exist? Yes, it's called a relation. But it's not a function because I found at least one x value that corresponds to two different y values. Therefore, this is not a function. Is it possible in real life? Yes. But it's not a function. Okay. So that's one way of identifying functions. Here's another way. We normally call for a function, and even for a relation, we call this domain. All possible values of x. And we call this range. And it can be the domain of the relation. It can be the range of the relation as well. Good. Now, what if we are given some graphs? And I do have the handout that I have from your professor, which I really liked. So we have some graphs here. I don't know if these are visible. Are they visible or not really? Maybe they're not. Maybe it's too small. So let me just graph something myself. Okay, so here is a graph. And here's another graph. And let's suppose we're asked to identify which graph represents a function. Well, we have a method. And the method is called vertical line test. The idea is the same. For each x value, only one y value. For each x value, only one y value. Okay. I will draw a vertical line through the graph, not here. It's not relevant. Through the graph. And I realize that if I graph as many, or I draw as many as possible, or as many as I want, every vertical line will cross the graph in one point, and I will be able to read that y value. Not the same thing here. Through the graph, it's sufficient to show that I drew one vertical line, and I was able to read two y values for that same x value. For the same x value, I was able to read two y values. Therefore, this is a relation. This is a function. By the vertical line test, this graph represents the graph of a function. By the vertical line test, this graph represents the graph of a relation. Okay? Now, what if I'm given, let's say, x squared plus y equals 3x. This is an equation. And I'm asking myself, okay, allow me to